Hello everyone, welcome back to the channel. In today's video we will discuss about the other linear data structure, that is stack. So in the previous video we have discussed about the one of the linear data structure, that is array. Okay, the next type of the data structure in linear model is your stack. Okay, let us go and see what a stack is there and how it will be working, and what are the different ways to implement a stack, and what are the different applications where this stack can be used in real world, right? So this will be our today's agenda. First, let us see what is a stack. The stack is a linear data structure. Okay, it is used to collect some objects, like how we collect the elements in an array. Similarly, stack is also a container where we can collect some data elements into this, and also these data items are also related data items. Okay, we can collect the related data items in this. So the basically this stack is as shown in this diagram. You can see this, it will be represented as a pile of those particular objects. In the first diagram you can see here, like in the first diagram you can see, in this diagram we can see that this is a pile of books here. Okay, these are the different books that are organized here. We have this particular pile of this particular books here. So similarly you can see a stack of plates here. Okay, for example, these are the plates that are kept on one after another. Similarly, some toys are taken here and they are kept one on another, right? So this is the basic representation of a particular stack here. So we are just going to take, so in array we have seen that, so in array we are storing the elements like this 1, 2 and 3. So whereas in a stack we are going to follow something like this 1, 2 and 3. So until some size we are going to fix, until then we are going to add the particular elements onto a stack here. The basic functionality of a stack is based upon a methodology. What is the methodology we are using here is LIFO is the methodology we are using. What do you mean by LIFO? Is last in first out data structure. Last in first out data structure. For example, if you see in this case, the first element that entered into the stack is, if I consider this as a stack, okay, so what is the first element that we are inserting in this? 1 is the first element. Next we are inserting second element, and next we are inserting the third element, right? 3 will be inserted here. So write 1, 2, 3. First one is, this is the first one. Who has entered into this one? Last. This one has been entered the last. So as you can see this diagram, one side it is closed and one side it is open. If you want to insert an element, you have to insert the element from here. If you want to delete an element, you have to delete the element from here only. Just imagine like a container that you hold a glass. Okay, if you want to fill the water into this, you can fill the water from this side only. If you want to spill out the water, take out the water, then also you have to take from this side only, right? You understand? So this is the basic terminology of a stack. So whoever enters the last, they will be coming outside. If I pop these particular elements, it will be coming 3, 2, 1 will be coming. So when I enter, what is the order? 1, 2, 3 is the order. First I entered 2, second and 3 I have entered. When I pop these elements, then 3 will be removed first, second 2, and then the first element will be taken, right? You understand? This is what known as a LIFO data structure. LIFO, last in first out methodology. So stack follows this particular methodology. Okay, next one is generally this if you consider in Java, this is available in the vector class. So that we will see when we go to the programming. Right, so and sometimes we can also call opposite to this one LIFO, we also can call the first in last out. Whoever entered this one first, so this person has entered the first and he will be coming last out, right? So that also is, we can also call it as first in last out also. So this is about the stack and stack linear data structure. So let us go and see what are the basic operations of a stack. Okay, generally these stack is having two major operations. So the first major operation is push operation and the second operation is your pop operation. Okay, instead of them and also we do also have like operations like peek is empty, is full, right? These are the some of other operations those are available. So what do you mean by push operation? Push operation is used to insert an element to the particular stack. Let us assume this is a empty stack. If I want to insert this element here, so what I have to do, I have to write it like push of 1. So then what happens, the element 1 will be pushed onto the stack, right? This is just like a function or a method that you write in your Java programming language or any other particular programming language. Its work is to just insert the value into this particular empty stack that is created. So similarly, we also have some pop operation. What is a pop operation or pop function? If you want to remove or if you want to delete the element from a particular stack, you want to take out of this some elements that is stored here. For example, here like we have done push of 1, right? So after that we can also write, next one is we can write just like push of 2. So second element is done. So next one is I'm calling again push of 3, right? So 3 elements are inserted into my stack here. So now I want to remove the third element. So then what I will do, I will call this particular pop function. Just for example, just I will call pop for one time. So the whatever the element that is on here on the top of the stack, that will be popped outside. So again if I call another time pop, so again the next top element will be popped outside, and if I call again, then what happens, again another element will be coming outside of my this stack. So these are the basic operations, right? Similarly, what is the peek here? Peek is nothing but it will return the element that is on the top of the stack. So for example, in this case, the element, if I call peek here, in this particular case, if I call the peek here, for example, imagine that my stack name is s.peek, then it will return the 1 value. So in this case, peek will be like 2 value. In this case, peek value will be 3, right? Whichever the element is on the top on the stack, so that will be returned here with the help of the peek here. So similarly, if you want to know that whether this stack is empty or full, okay, why I want to know that whether it is empty or full? For example, if it is empty, then I cannot remove any element out of that, right? So I cannot use this pop operation when this stack is empty. If nothing is there, what I can bring out? Nothing, we cannot bring it, right? So that's why we have to check before we are going to pop an element. We have to check whether this stack is empty. If it's empty, we cannot do that operation. So that's why we are going to verify this operation. Similarly, whenever the stack is full, let us assume this is the maximum size of the stack and stack is already full. Okay, now I am trying to insert an element, push an element into this stack. That is not correct, right? You cannot push an element where it is already full. Okay, there is a like let us assume this is a glass. Okay, it is already full. So now if you are trying to pour some more water, means what happens? It will be overflowing, right? So before inserting the value, you have to verify that whether it is full or not. If it is full, then you cannot insert that value. If it is not full, in that case you can insert an element. Similarly, if it is empty, then you cannot pop any element outside. If it is not empty, so then what you can do, you can pop the element that is on the top of the stack. So that's why, so these are the different operations like push operation, pop operation, peek operation, is empty, and a full operation. So right, I hope you understood what are the basics operations of a stack here. Right, let us go to the next one. So whenever we work with a stack, we used to have two conditions. We have to verify the two conditions as I told you in the previous one. So first condition is known as overflow condition. So what do you mean by overflow condition? Let us assume that I have a stack and the stack size is 3. Maximum size is 3. So how many elements I can store in this stack? I can store only 3 elements, 1, 2, 3. Or A, B, C I have stored here. So now if I am trying to push another element, like for example I am writing push of 4. So what happens? It will overflow, right? Max, if whenever the top value is like max minus 1, so it will overflow that particular value. Okay, already stack is full. I cannot insert any more further elements, right? So that condition is known as your overflow condition. Okay, similarly in another case, let us assume that I have a stack of same size 3, but unfortunately I don't have any elements in this. I have popped all the elements in this. Okay, so now in this case what happens? In this case it is going to underflow, right? If I am trying to pop any element from this, if I execute a pop method into this particular stack s.pop, let us assume this stack name is S, and if I am trying to write s.pop, in this case it will return me the underflow state, because there are no elements in this stack. Okay, you cannot take out any particular element from here. Hope right, it is clear, I think, right? Those are the two cases. So whenever you are inserting, you have to verify the overflow condition. Whenever you are popping the element or removing the element from a stack, you have to verify the underflow condition, and then you have to go to the next operations. You can perform those particular operations there. So now how would I know this, whether the stack is overflow or whether the stack is underflow? Okay, for this we have a pointer. So pointer, what is this pointer is? This pointer plays a key role in the working of a stack. So it will play the key role in the working of a stack. So based upon this pointer, we can know that whether the stack is full, whether the stack is empty, whether the stack has a maximum number of elements, or whether it has one element, or whatever it may be. Different conditions or different status, whatever the status of that particular stack. To know those particular status, or to know the condition, current condition of a particular stack, we can make use of this pointer, and the pointer name is what? Top, top, and the pointer name is top. Okay, by default when we create a top, like a stack program, so implementation, we assign this top value as -1. Right, so for example, by default it will be top is equal to -1, which indicates that stack is empty. Like this, the stack is empty here. So as we can see in this case, the stack is empty here, right? So there are no elements. So in this case, top value is -1. So I'll just write t is equal to top minus, that is equal to -1. Next one is, for example, let us assume that I have to define the stack size. Whenever I create a stack, I have to specify the size of a stack. Maximum I can enter 3. Okay, 3 elements I can store in this stack. So in this case, I have created a stack, right? So starting value will be 0, because we will implement with an array, then it will be 0, right? 1 and 2 value it will be 0, 1, 2, just index values. These are the index values. So how many elements are there? 3 elements are there. So whenever this top reaches, top is equal to max -1. Okay, what is the max value here? 3. So top is equal to 3 minus 1, that is equal to top is equal to 2. So whenever the top value equal to 2, so then what is the current status? The stack is full. So this one you have to understand. Next one is, for example, let us assume that I have used a push operation and I have inserted some 10 value here. So whenever I insert a 10 value, so automatically top will be moved from -1 to 1. Whenever we increase, whenever we insert a this particular push operation, before that what happens? Top will be incremented by 1. Top is equal to top plus 1. So already it is -1. So when you add this plus 1, then what happens? Automatically top becomes 0. So let us assume that if top value is equal to 0, then there is one element in that particular stack, right? So next one is, whenever you want to insert an element, as I told you that top is equal to top plus 1, you have to perform, right? Similarly, for example, whenever you are popping an element from a particular stack, s.pop, so in this case what happens? Top is equal to top -1, so from here the top value will be minimized, right? So a step it will be coming down, so to indicate the next element will be the top of the stack. So right, so that is what we have to perform here. Before pushing an element, verify whether the stack is full or not, because it will lead to a overflow state. So similarly, before popping an element, you have to verify whether the stack is empty or not. So otherwise it will lead to a underflow state. So those are the different conditions. I hope you understand what are the conditions and what is the pointer variable that are using, and what are the different conditions of this particular pointer variable. This is very key in when you implement a stack here. So here you can see different operations and their code for this particular operations, right? So these are the some operations. When we go for the code, right, we will see about these particular operations. So what are the various applications of a stack? So there are different applications where we can use the stack in real world. Like for example, let us assume that you want to reverse a word. For example, I have given a word like stack itself was my word. I want to reverse this one. What I will do, I will create a stack here. I will insert first S, and then I will insert T, and then I will insert A, and then I will be inserting C, and then I will be inserting K. So now what I will do, I will pop these elements. First what it will be K, C, A, T, S. So this is the reverse of this particular word, right? So to do this type of operations, we can make use of a stack here. Similarly in compiler, so when you work with the different types of arithmetic and logical these expressions, right, there we can make use of there you can syntaxes. When you check the syntaxes and expressions evaluations, there we can make use of this particular stack, right? So and also when you use the operating system, like similarly like process scheduling, when you do the process scheduling, there you are using keys like before in other operations, like where related to operating system, sorry, where process scheduling comes to the queue. So like other operations we can use in operating systems also we can use. So for example in browser generally it is used, like for example we have two options like move forward and move backward, right? Move backward and move forward. So let us say you are in a particular page, you want to go to the previous page, then you are clicking this one. So here you can make use of a stack here. So similarly we can use for the expression conversion and evaluation. We have different types of expressions like infix expressions, on prefix expressions, okay, and also we do have like postfix expressions. To evaluate these particular expressions like a plus b, okay, plus ab and ab plus, right? So this type of expressions if you want to take, no, so there also you can use. And towers of Hanyu problem is there, like where 3 towers will be there, so there we can shifting the rings, so that we will see further. These are the some of the applications of your stack, right? So this is all about your stack and the basic methodology of a stack. So now for example if you want to learn implement this stack, okay, very important part is this is all about theory. Next one is coming to implementation, right? So implementation is of two ways we can implement the stack. That is, first one is using arrays, we can do it. Second one is we can use a linked list, right? Two ways we can implement this one. So but Java providing some ADT, okay, Java has provided you some ADT. So this ADT is nothing but in vector class we are having this ADT, so we call it as a stack ADT. By using this stack ADT, no need to write the code for this push operation, pop operation, is empty, is full, peak operation. For all these no need to write the code again, okay? In stack already we have all these particular methods, like push method is already written, pop method is functionalities written, peak is written, okay, is null, and all these methods are predefined, ready-made, available, interfaces are available already. So you can just directly create a integer stack. If you want, you can create an integer stack. So just like a declare, just how you declare like a variable, integer variable, so you can declare a stack integer, okay, s1 equal to new stack. So like this integer, if it is integer, just we can declare a particular stack, okay? With the help of this s, you can push the elements onto a stack. So you can specify the size of the stack, and similarly you can pop the elements, and also you can see is empty, s dot is full. So like this, okay, we already have the predefined. So in the next part of the video we will see like how to write the code of a stack in your ADT, and then we will see how to implement a stack from scratch using your arrays. And then once we cover the concept of linked list, then we will see the how to create a stack with the help of linked list. So we can consider this as three parts. Part 1 is theoretical one, part 2 is like basic implementations, one implementation in your like ADT and array we will be seeing, another implementation will be like linked list. So and also part 3, what we will do, we will see like we will see the applications of a stack. So how to evaluate a expressions, different types of expressions like your postfix expressions, how to evaluate them, how to find the value, and we will see how to convert a infix notation to a like a postfix notation, or a infix to a prefix notation. How to do this one we will be covering in the next upcoming 2 particular parts. So hope you understood this basic concept of a stack. So in this video we'll just summarize it. So what we have discussed is, we have discussed that what a stack is, how it is represented in real world, and next one is we have discussed it like what are the different operations of a stack, and then we have discussed it like what are the different conditions of a stack, and then we have discussed it like what are the pointer that is used in a stack and what is importance of this pointer in a stack, and then we have covered like what are the different applications of a stack, right? So in upcoming videos we will be covering more in depth like how to implement this with the help of the code, and also we will see how to see various applications, right? So hope you understood and gained some knowledge regarding stack here. So if you like this, please share it with your friends, and consider subscribing to this channel, and please like the video if it was useful. Thanks for watching. See you in the next video.